And now we're going to enter the center of this chapter, or the most important piece of this chapter, and it's the hard. It is hard. So we're going to work our way through these problems. We're going to get our, get an idea how to do them. Once you get the process down, it gets easier and easier as you go. We're going to ask the question. First question we ask: what are we asking for? We're asking the question: is this thing convergent or divergent? In other words, I give you a series. Does it converge towards a number, or does it diverge and essentially have no limit? It's going to go out to infinity. That's the question at hand. We know that if the ratio, if it's a geometric series, and the ratio is less than 1, then it's going to be convergent. We can even calculate where it is. But for other series where things are messy, it becomes a little trickier to figure out what we're doing here. We might look at something and say that's clearly convergent, but how would we prove it? We don't have any test for that. And so now we ask a question, and it's a simple question. It's either, is it convergent or is it divergent? And we need a test for that, okay? So what test are we going to apply to this? The test we're going to apply to this is called the ratio test, which means we are going to try to figure out what the ratio is. Not at the beginning, because that doesn't matter. We want to know what the ratio is when we get out here to infinity land, okay, near the end. And so we're going to go through and we're going to try to discover what the ratio is as we get close to infinity. If the ratio is less than 1, then we know it's convergent. If the ratio is greater than 1, we know it's divergent. And that's the way the game is going to be played. So let's start off. I'm going to do example number 1. Example number 1 is 1 times 2 over 2 to the 1 plus 2 times 3 over 2 to the 2 plus 3 times 4 over 2 to the 3 plus 4 times 5 over 2 to the 4th plus dot, dot, dot. Is it convergent or is it divergent? And again, we don't care about it at the beginning. We want to know at the end. In order to figure out what it is at the end, the first step is going to be to figure out what the nth term is. In other words, if this is the first term, and this is the second term, and this is the third term, this is the fourth term, what does the nth term look like? Okay, so look at the first item. The first item on here is a 1, then a 2, then a 3, then a 4. A 1, then a 2, then a 3, then a 4 for the first, second, third, fourth term. So the nth term would just be an n, agreed? Second one is 2, then 3, then 4, then 5 for 1, 2, 3, and 4. So that's just n plus 1. And then on the bottom is 2 to the first, 2 to the second, 2 to the third, 2 to the fourth. That would be 2 to the nth, right? So that would be an nth term. Okay, so again, I looked at this. I said this is the first term, looks like this. Second term looks like this. Third term looks like this. Fourth term looks like this. What does the nth term look like? Well, first term 1, second term 2, third term 3, fourth term 4, then that's an n. If the first term is 2, second term is 3, third term is 4, fourth term is 5, it's n plus 1. If the bottom is 2 to the first, 2 to the second, 2 to the third, then it's 2 to the nth. Now, once you find the nth term, you're going to find something else too. You're going to find the n plus 1th term. The nth plus 1 term would be, in this case, the next term, which would be n plus 1, n plus 2 over 2 to the n plus 1. Now, it's not immediately obvious why, but we're just adding 1 to everywhere I see an n. That tells me what the n plus 1 term is. So what is the ratio? What is the ratio between all of the terms? Well, the generalized form would be the n plus 1th term over the nth term, right? The previous term. And since we're leaving it general, we're going to use the generalized form that we just figured out. As that would be n plus 1 times n plus 2 over 2 to the n plus 1 all over n times n plus 1 all over 2 to the n. Now, this is almost always going to lead to a flip and multiply situation. So you're almost always better off just go ahead and start with flip and multiply, but I want to show you what we're actually doing. So n plus 2 over 2 to the n plus 1 times, flip it, 2 over n times n plus 1. Now I'm going to simplify. Now to simplify this, I got to do a little work, a little thinking, keep my brain on full speed. So here's what I'm going to do. I'm going to look at this. I got an n plus 1 on top, n plus 1 on the bottom. I'm going to go ahead and cancel those two out. I'm going to notice I got an n, 2 to the n, and 2 to the n plus 1. Means I got one more 2 on the bottom than the top. So I got n plus 2 on the top, and I got a 2 from here, one more than this, and on the bottom. So this is my ratio. And indeed, if I'm careful and I look back, this is my ratio for all terms. So if I look at this, go, wait a second, is that really my ratio? Let's look at the first term. The first term would be 2 over 2. And the next term would be 6 over 4. Agreed? So that would be 1 followed by 3/2. So what does this tell me? My ratio between the first and the second term would be, well, if I put a 1 in there, I get 1 plus 2 over 2 times 1, I get 3 over 2. So my ratio would be 3/2. So indeed, I'm multiplying by 3/2 to get from my first term to my second term. But again, I'm not interested at the very beginning. I'm interested when this gets to infinity. So how have we learned to look at it when it gets to infinity? We're going to take the limit as n approaches infinity, as my terms approach infinity of my ratio. Well, my ratio is just n plus 2 over 2n. Now, hopefully you remember, because just a couple weeks ago you were supposed to have this memorized. How do you figure out what the limit as n approaches infinity is? You divide by the highest power of n, you find any worth expression, which in this case is just n, right? Multiply top and bottom by 1 over n. I get 1 plus 2 over n over 2. I'm still taking, whoops, I need a little room there. Still I'm taking the limit as n approaches infinity of 1 plus 2 over n over 2. So I put infinity in there. That just simply becomes 0, right? So I get 1/2. So my ratio, the closer you get to infinity, I'm going to start with 3/2, right? We did the first one. But my limit as n approaches infinity is 1/2. So is this less than 1 or greater than 1? It's less than 1, so we write the word convergent. If it is 1, we write can't tell. Test can't tell. If it's greater than 1, then we can say it is we're 100% sure it is divergent. Fair enough? Alrighty then. So the steps are, look at the original terms, figure out the nth term. Use that to figure out the n plus 1 term is. Once you have those two terms, you write the ratio as the n plus 1 term over the nth term. You then simplify, take the limit as n approaches infinity. If it's greater than 1, it's divergent. If it's less than 1, it's convergent. If it's 1, you can't tell. Roger that? All right. Try problem number 1.